In this video, I'll be looking at something that's not so much Blender related, but you'll notice going forward on this channel, I'll be creating videos on more and more topics that I find interesting. Sometimes they might be related to Blender, sometimes not. I'll still be making the Blender videos, but I'll be doing videos on more topics that I find interesting and sharing my discoveries as I continue to learn. So with that said, let's just go ahead and look at why. Now, while it's possible to import an SVG inside Blender and play with it using the curve settings in Blender, you really lose a lot of what makes SVG special because it's an image format that was really designed to live inside the browser. So while most images, regular images, are raster images made up of these tiny little pixels, SVG is a vector format where the image is drawn by shapes defined by math. And there are a lot of advantages for drawing images like this in the browser, like helping the websites to load a lot faster and having like crisp images that remain sharp despite how far you zoom in and out, so you don't get that kind of blocky pixelated look. So there are all these advantages you get for using SVG inside your websites, but I'm particularly looking at SVG just purely from an artistic perspective. So just like Blender comes with a few primitives that you can grab and drop inside your scene and start playing around with, SVG also comes with a few primitives that just help you draw simple shapes and render them inside the browser. So the code on the left is what is drawing out the shapes on the right inside the browser. So you can just ignore this top part. These are just a few definitions to set up your SVG. So if you see here, I'm using the primitive rect used to draw rectangles, and I'm telling it to begin the drawing at position 74 pixels on the x-axis and 17 pixels on the y-axis, so this position right here. And I'm telling it to give this rectangle a width and height of 30 pixels, so that draws a square. And then I'm telling it to fill in the color with black. And for the circle, it's similarly, I'm telling it to draw a circle with the radius of 17 pixels, and the center of the circle should be at position 90 pixels in the x-axis, 77 pixels in the y-axis, so this position right here, and filling it with the color black. So if, say, I wanted to change the color here, set it to something like red, set this to something like green, and then set this to something like blue. Then I close this. So if I save this and then I reload that page, you'll see how the drawings are updated. So these are not all the primitives that SVG comes with, but this is just kind of an illustration to show you how the code translates into the image. But then you don't have to really understand and type out the code to draw out the shapes to make the drawing that you want to make. This is where programs like Inkscape come in really, really handy, because you can now interact with these shapes without having to look at the code, just like how you play around with Photoshop or Krita. You can draw out these vectors as if you're drawing out an image. And then if you understand the code, you can now start playing around with it and tweaking it to do really cool things with just very slight programming. And we'll see that a little later in the video. This ability to edit an SVG image as an image inside a software like Inkscape and as code, I think this puts SVG in a very unique position inside the world of digital art. And I think it's created two different types of vector artists. There are those who look at their image as an image going into the code, and there are those who look at their artwork as code going out to create an image. And until recently, it wasn't really possible for the second type of artist to capture the value of their work as art. The most you could do was maybe just create cool animations inside the interface of your website or your app. But it's now become possible for these artists. They're being empowered to lean into what becomes possible when you start integrating code inside your artwork and to appreciate creative coding as an art form in itself. And I think this is what has made platforms like Artblocks as successful as they've become. And more, I think we're going to see this type of artists really grow into their own. But in this video, I won't be going that deep into the code. I'm not even much of a programmer myself, but I think there's so much room to play around with inside this spectrum, even if you just understand a little bit about how SVG code works. And that's what we'll be attempting to do inside this video. So in the recent past, it's become a bit of a hobby of mine to create these types of portraits using Inkscape and SVG. And as I was just learning about Inkscape and getting behind the code of the image, I started asking myself, just in exploring the space of what's possible when you play with the code, would it be possible to create the illusion of these portraits growing old? And it turns out that it actually is, and using very simple rudimentary tricks. And you would ask, why not just create the portrait and take it into somewhere like After Effects and create your animation that way? And I think when you're animating it as footage, you're kind of limited by, you have these limitations that you wouldn't have on the code side of things. Say if you wanted like a 10-hour animation, you're limited to the size of the file that you would have to create in that case. Whereas in the code, the browser is just running this code in the background, and as long as the person is there viewing it, your animation would be doing what it's expected to do. So there are kind of these things that become possible when you now start playing around with the code. So what I'll do, I'll go to the website thispersondoesnotexist.com. And every time you refresh this page in this website, it generates a new portrait of an imaginary person. These images are generated by AI. So I'll just go through and scroll until I find a face that I like. And preferably, I'd like a face that's like facing me directly forward. And I probably won't use the face of a child because there are a lot of changes that occur as a child ages to become an adult, which is kind of tricky to emulate with the simple technique that I want to use. So I'll just go through and scroll until I find a face that I like. And I think this is cool. So I'll take this and use it. So just save image, and then I'll save that as a JPEG. Good. And then the next thing I'll do is I'll take this photo, this portrait, and I'll run it through the Face app. I'm sure you've seen this app somewhere. There's a time back, a few years ago, it went viral. I'll pass it through this Face app and generate an aged version of this same photo. And then I'll take these two photos into Inkscape and start playing around with them in there. Now, the idea here in Inkscape is to take these photorealistic looking images and breaking them down into really simple shapes and countable layers of detail that make it easy to work with. So the first layer of detail I'll extract are the outlines, and these are what give the shapes on the face and the features on the face their boundaries to capture that likeness. And these outlines are also what will have the darkest colors in the image. For the hair, I took 2 layers of detail, so I'm using the pen tool to just shape out the bright parts of the hair and the darker parts of the hair. And the shape forming the darker part, I'm putting it underneath, and the brighter parts above. And those 2 layers are what give the shape of the hair the definition. With the outline of the face done, I'll then go and start capturing the shadows inside the crevices of the face. And I'll take 2 layers of detail for this. Depending on how detailed you want your portrait to look, you can use however many. I tend to use between 2 and 4. And with each layer or each next shadow behind the darker one becoming lighter and lighter. And for this one, I found 2 layers of shadows worked for the kind of look I was going for. Now, I thought I had kind of shot myself in the foot when I realized I had picked a portrait with a beard in the young version. But then I realized that because in the SVG it becomes an independent shape, by including the beard in the animation and having it completely transparent in the young version, it just exaggerates this illusion of aging in the overall effect. And then I'll go back into the face and capture the second layer of the shadows, which will have a slightly lighter shade of green than the original one. You'll notice that so far there's nowhere in the image where I'm using gradients to color the shape, but inside the eyes, I'll use a gradient to just give the eye a lot more detail, because the eye just tends to breathe life into the face of a human. So by using gradients to just draw attention into the eyes, I think it just breathes a lot more life into the portrait. With that done, this covers all the layers that we need for the young version of the portrait as an SVG. Remember, all these shapes that we are drawing, they're being translated into code on the back side. I'll then swap out the younger reference image for the older one. And like I did, I'll go in and create 2 layers of detail for those wrinkles that are really prominent in the older version of the portrait. And the idea is that I'll just take these 2 layers of detail in the older version and animate their opacity along with the beard and the color of the hair to create this illusion of growing old. Now, there are a lot more sophisticated things you could be doing to really hone in that effect. For example, you'll notice the shape of the face kind of changes and distorted in very subtle manners, and the ears kind of become bigger. But then you need a different approach to kind of effect that look inside the animation. But I think this trick of just animating the opacity works well enough for what I'm going for. So this is what we have so far in terms of the drawing. And we now have all the shapes that we need to do what we want to do. And if I just zoom in here and grab a bunch of these shapes and the beard, if I just move these aside, you'll see a bit better what we are doing. So I have 3 shapes: the outline, the first shadow, and the second shadow. And these are what pretty much make up the young version of the face. The eyes will remain as they are. We won't be touching those. And even these shapes that make up the young version of the portrait, we won't be touching those. As for the hair, we have 2 shapes that make up the hair, and we'll only be animating the color of the hair to create that kind of graying out effect of the hair. And then we have 3 more shapes that will be animating the opacity. We have the beard, and we have the 2 layers of wrinkles from the old version. And these are what we'll be animating to just create that whole effect. Now, before we go and start looking at the code, there's a few tools that Inkscape gives us that can just help us to, if you're not so conversant with looking at the code and prefer to look at an interface, there's some setting up we could be doing here before we go and start tweaking the code. So if I select the outline and come to this XML editor window here, when you select an object, you're given a few properties that you can tweak here. So I'll name the ID to outline. And then if you click here, all these numbers, all these figures that you see here are just the points that are defining all these points that make up the shape. So when you go to look at your code and see a bunch of numbers, don't be confused. You don't need to know how to read all these numbers. Just know that the object that you select, these define the points that you have in that object. And then under style, this is now where you're defining what that shape looks like. So here you see we are filling it with this color, filling it with an opacity of 1, with no stroke, and on and on and on. And these are the values that will then be animating inside the properties of the object later on. So I'll just go through naming all these objects so that I can be able to identify them inside the code. And then I'm going to save this as a plain SVG. On a much simpler example, this is another shape that I drew inside Inkscape using the pen tool. And all the shapes you draw using the pen tool are defined as paths inside the code. So this block of code here is what is determining what this shape looks like when it's rendered in the browser. And these numbers that you see here are what are defining the points that are joined to create this shape. And if you look at the code of the portrait, the original portrait, it looks super, super crazy, like something out of the Matrix. It looks complex, but all these numbers look like this because the shapes that we are drawing are a lot more complex. But in a nutshell, all those objects inside the portrait look exactly like this. It's just that this part here looks a lot more complex because the object is a lot more detailed. It has a lot more points that are being joined together to create the object. Now, to animate an element of this simple shape that we have, how would I go about doing that? So here we've defined an element path and then set up all these parameters as to how it looks and closed it out like this using a / and closed out that bracket. But to animate it, I'm going to close it out in a different way. I'll remove that / and then come here, open that, and another /. So this has just pretty much done the same thing, but I have added for myself some space inside here from where I've opened the element and where I've closed this element path. Inside here, I can add a bit of code that I can use to now animate any of these attributes inside the style. So I will paste in this code, and this just says that I want to animate the attribute with the name fill opacity from the value of 0 to a value of 1 within a duration of 3 seconds. And when that's done, repeat this indefinitely. So this fill opacity is this attribute here. So I'll just set the initial value to 0. And if I save this and reload the page, you'll see that the opacity is animated from the value of 0 to 1. And when it's done, it repeats indefinitely. And this is pretty much all the animation we'll be doing on the different layers of the wrinkles and the beard and the color of the hair to just get that animation to loop indefinitely. So this is currently as far as my current coding skills can take me, but I know that this barely even begins to scratch the surface of what becomes possible if you start looking at SVG in this way. So to kind of give you an idea of what I'm getting at, there's a line here that stood out to me as I was reading the Inkscape documentation. It says here that a drawing saved in one version of SVG by one version of a drawing program should be viewable to the full extent possible by any previous or future version of any drawing program that adheres to the SVG standard. So this just means that SVG is designed to be as future-proof as possible. So theoretically speaking, whatever version of Brave or Chrome or browser that you'll be using 20, 30, 50 years from now should be able to correctly render an SVG document as long as it adheres to the SVG standard. And to take that even a step further, so currently when you're minting your artwork, the image is usually stored in some form of decentralized file storage system like IPFS or Arweave, but using SVG, it's possible to have the actual artwork live on chain, on the blockchain. So there's this project that I really, really like. It's called Luchadors. And if you look at the artwork for this project, all these tiny little characters are drawn inside the contract of the project. And because the contract has already been deployed on Ethereum mainnet, it means this artwork will exist as long as Ethereum will exist, which is pretty much as long as the internet will exist. So it's kind of crazy to think about that. It's theoretically possible that 150, 200 years from now, these characters will be viewable and be acting and behaving the same way that we are seeing them right now. And I think this just opens up like a whole world of exploration that SVG makes possible when you start thinking about the interactivity of this artwork that's also code that can live forever inside the contract on the blockchain. So all these characters with all their traits and all the different colors, even including the animation, is all done on chain inside the contract. So I think this is really, really, really cool. I think this is the first project I ever saw that actually put the art on chain. Like I mentioned, I'm not much of a programmer, so if there's anything I don't get or I got wrong, feel free to tell me down in the comments. Also, if you can think of a name to give this guy, also leave it down in the comments and we'll pick one from there. So I've made a collection of a few of these portraits, and I'm giving the artwork out for free in the public domain, and I'm making the code open source. So feel free to grab them and play with them, take them in whatever direction you wish. I just think this was a cool concept. It's not much of a technical achievement, but I think the idea conceptually is really cool and can be built upon in many different directions. So feel free to grab them, go ham, do share if you make something from this. And yeah, this was really fun, and I will see you guys in the next one.
When I first saw you, I already knew you're a special one. You're not like them. When I got to know you, I already knew you're worth it all. You deserve the world. Your past ain't pretty, but you still give love. I see strength in you, that's why I stick around. Baby, I'll fight. Always be by your side. Yeah. When I first saw you, I already knew you're a special one. You're not like them. When I got to know you,